Hi guys. In this video, I want to talk about getting started with runnable objects. I don't feel that the chapter in the book on multi-threading really does a good job of explaining kind of why you would use a runnable to do any particular thing. So let's just start from there, and I'll show you guys just a real clear-cut example of the power of runnable objects. And I'm going to start with kind of a silly example. Well, yeah, let's just call this runnable demo. All right, here's our main class. All right, so we'll come back to the main class in just a second. When you are making a runnable object, you can kind of think of runnable objects as tasks. Basically, little mini programs that your program needs to do. So this task, let's call it counter task. Okay, and every class that implements the runnable interface needs a method called run. Okay, so this is where the task code goes. And this task could be anything. It could be any operation, repeatable step, or anything like that that your program needs to do. And again, you can kind of think of this as just like a little mini program or a small slice of your total program. So what I'm going to have this task do is we'll have a for loop going from 0 to 100. And actually, hold on a second. Let me change my resolution here. Hopefully you guys, I want you guys to be able to read this. Okay, there we go. Should be easier to read now. So inside of our counter task, inside of its run method, we're going to have just a simple for loop that prints out the value of I from 0 to 100. Okay, that seems like a pretty trivial program. And it's back here in the main method. We'll just create a counter task object and we'll run it. No problem. Okay. Now we haven't really done anything worthwhile here, except take this little loop and put it off in a separate method. To make things a little bit more interesting, I'm going to have this task call a method called thread.sleep. And what thread.sleep does is it tells this current task to stop running for some preset amount of time. And this time is in milliseconds. So I'm going to have it sleep for 100 milliseconds, which is 1 second. Now, calling the thread.sleep method, the static method, can throw a checked exception. This needs to be surrounded with a try catch. Essentially, what's going on with this exception is that when you tell part of your program to sleep, if something interrupts that sleep process, it will cause an exception. So what we're going to see here is our program is going to start at the number 0, print it out, and then wait 1,000 milliseconds, which is 1 second, and then it will print out the number 1, so on and so forth. So approximately every second, the sleep method is not exact. Approximately every second, it's going to print out the next number in the sequence. And this is going to take some time. So we won't wait. So again, we haven't really done anything sophisticated here. We've essentially taken some pretty normal code and we just stuck it inside of a separate method inside of a separate class. And if that was all that tasks or runnable objects did, you'll hear the book use the term task or refer to these as task classes. Basically, any object that's runnable, the book may refer to as a task. If that was all we could do with a runnable object, it would not be particularly powerful, okay? So let's, instead of just having the task run by itself, we can tell our task to run in parallel. Tell our task to run at the same time that we want to do some other task. So the way we do this is by creating a thread object. And in the constructor for the thread object, we give it the task that we want it to run. Now, you'll notice that I got rid of the line where we actually call ct.run. That's because when you use a thread to run a task, it will run it automatically for you. All that we have to do is tell the thread to start. Now, this will do exactly the same as what we had before. Okay, no difference. But what if we wanted 2 counters going? Call this CT2. Call this some other thread. Now, in a normal program, if we called this ct.run method, we would need to wait for this entire for loop to complete before we could actually call the run method of the other task. However, because we have assigned these tasks to run in separate threads, they will actually run simultaneously. As soon as this thread gets started, we will create the second task, assign it to a thread, and start that thread as well. So we will actually have this loop running twice as part of 2 different tasks. So we've got 2 counters going. We can highlight this even further. Let's give our counter task a constructor. And we'll give it a name. And whenever we print out I, we will also print out the name of that task. We'll call this counter 1, and we'll call this counter 2. Oh, sorry, forgot to do my assignment statement. Can't forget that in the constructor. And there we go. We've got 2 counters running side by side at the same time without waiting for one another. Now, the really interesting part about this is that while these threads are running, we can continue to do other stuff in our main method as well. We can see that it prompted us to enter our name. That does not stop the counters from counting. And in fact, even though the counters are counting, that scanner is still waiting for us to enter our name. And the main method is allowed to continue uninterrupted while the counters keep counting. And that is the basic power of a runnable object.